You have started the topology and power part of the webinar. As you can see on the slide, the failure of one device in a star topology can result in the loss of connectivity to a large part of the network. This is generally unacceptable, especially in security video systems. The standard for safety systems therefore recommends the use of a redundant topology so that the average system failure time is at least 16,000 hours. The solution can be a LAN ring topology with very fast reconfiguration or a network topology controlled by the RSTP protocol. Choosing a specific redundancy solution should take into account possible risks. With the LAN ring topology, there is no risk of interruption of the connection between the cameras and the recording device thanks to a very fast reconfiguration within 30 milliseconds. For RSTP, the switching time can take up to 2 seconds. This will cause the TCP connection with the camera to be interrupted and it will have to be re-established. If uninterrupted system function is required, it is also necessary to provide a backup power supply, which we cover on the next slides. You can use LAN ring switches in a number of topologies such as point-point, bus, star, ring or mesh. There can be up to 255 independent rings in one system. As mentioned on the previous slide, optical rings are the most efficient in terms of switching speed. We recommend connecting a maximum of 30 switches to them. The limit of 30 switches per ring is only for the reason that there are not too many switches dependent on the backup route in the event of a failure. The system is still working, but in the event of a second fault, there is already a risk of an outage. So if you absolutely need to connect multiple switches in a ring, it is possible. Another option to ensure redundancy is spanning tree protocols. Switches enable RSTP protocol support to be turned on. In that case, the switches can be connected in basically any way. Another option to ensure redundancy is spanning tree protocols. Switches enable RSTP protocol support to be turned on. In that case, the switches can be connected in basically any way. Another option suitable especially for large systems is the multiple spanning tree protocol, which appears in G-series switches together with the third generation of the LAN ring protocol. The table shows the speed comparison of individual protocols. In order to maintain compatibility with all older generations of switches, the first version of the LAN ring protocol is also available in the latest versions. We refer to our version of the RSTP protocol as RSTPM. It is faster than common RSTP implementations, but at the same time guarantees backward compatibility with third-party RSTP. Stream sources such as IP cameras and NVRs do not send data evenly, but in so-called bursts. See chart on slide. This is also why, in accordance with the EN 62676-1-2 standard, a minimum 25% reserve must be observed when planning the load in individual network segments. If this margin is not respected, there is a risk of port buffers overflowing and Ethernet frames being dropped. You can monitor the load of each LAN ring switch port through statistics in the Simuland application or popular monitoring software such as Zabbix, Nagios, and others. For network traffic analysis, we recommend using the so-called Allegro network multimeters. The analysis itself takes place online or later on the data stored on the SSD disk. If you are interested in this service, write to support@metel.eu. All switches have at least 2 independent power inputs. For example, the box series switches are equipped with two inputs with a wide range of 10 to 60 volts. When end devices are powered by s.r.o, the supply voltage must always be at least 48 volts. We recommend monitoring the power supply status via the SNMP protocol. There are basically two options for reading the status. The first is SNMP get, where values are read periodically regardless of their importance. The second, more effective method is the so-called SNMP trap, where you first set a safe range of supply voltage for the power input. The switch then spontaneously sends SNMP traps only if the voltage changes outside the set range. Selected switch type certified as a transmission route for Asset, Galaxy and MB secure systems. In this case, they must be powered from a backup source meeting the requirements of the EN 50131-6 standard. The power consumption of box-certified switches ranges from 3 to 8 watts. This must be taken into account when calculating the size of the backup battery. Redundant power inputs are also available on 19-inch switches with 8 to 24 PO+ ports. They contain an internal power supply of 320 or 750 watts. There are two more independent inputs of 10 to 60 volts available on the rear panel. 20G2X8C backbone switches also have redundant power inputs, where on the rear panel there are two 230 volts inputs connected to two independent internal sources. That's all for the content of this webinar. Finally, I would like to mention some information about the test procedure and the subsequent issuance of certificates. Tests are only mandatory for people registering projects on our website and in the case of applying for an extended warranty of 5 years from the end of production. In both cases, you must have a valid certificate and activated VIP access on our website. The VIP account is activated automatically after passing the test. We consider a test with at least 2/3 of the answers correct to be a successful composite test. You have 2 attempts to pass the test each day. The validity of the certificate and VIP access to the website is 6 months. During this time, you can extend your VIP status at any time by taking another test. Another way to get VIP access is to participate in face-to-face training. In this case, your VIP access is activated for 1 year. Finally, thank you for your attention and I look forward to hearing from you on the next webinar.